Hello, everybody. So, most recently in my foray into climate science, I've been looking at the atmospheres of Mars and Venus and trying to think about these planets, both of which have a very high content of carbon dioxide in their atmospheres, and both of which have drastically different temperatures, and trying to compare them to the temperatures on Earth and the carbon dioxide concentrations on Earth, and seeing what I can learn and find out about the greenhouse effect from this, and also trying to apply mathematics to the situation, and trying to see how the equations given for instance, radiative forcing in with carbon dioxide levels, how that increases surface temperature. And I think I've made a few interesting discoveries, which I'm going to share in this video. And I think that there's still quite a lot of bullshit going around, frankly, in kind of climate science circles related to this problem, which I think is an outstanding problem and one which needs addressing. Because, for instance, with the equations for climate science that we have at the moment, it's not possible to reconstruct surface temperature using carbon dioxide concentrations, which is a big problem. And I'll get into why this is in due course. So, the first thing I did was look at the atmosphere of Mars, which has 70 times as much CO2 in it as Earth's atmosphere. However, Mars's atmosphere is only about 1% as dense as Earth's atmosphere, and it receives about 40% less sunlight than the Earth. So at the equator, Mars's temperature is roughly the same as Antarctica's, or the center of Antarctica. It's like about -60, -70 degrees Celsius or so. And then it's even colder at the poles. It's like -150 at the poles or something like that. So I thought that, okay, in spite of this lower atmospheric density, and in spite of the decreased amounts of sunlight, it still has far more CO2 in its atmosphere than Earth does. So it has 70 times as much CO2 as Earth. Uh, the 420 parts per million of CO2 in Earth's atmosphere has been thought to lead to 1.3 degrees of warming on Earth. So I thought very simply times, um, 70, the amount of extra carbon dioxide that Mars has in its atmosphere, by 1.3 degrees Celsius, and you arrive at 91 degrees Celsius, don't you? Which should be the amount that Mars is warmer by due to the carbon dioxide in its atmosphere. And scientists give obviously the explanation that it receives less sunlight in the first place, it's far less dense than Earth's atmosphere, so there's a lot less of a greenhouse effect happening, and they estimate that only 18 watts per meter squared is caused by of warming is caused by the amount of CO2 in Mars's atmosphere. So I was like, okay, retreating from that, let's look at an example of a planet which has a far denser atmosphere than Earth's and receives also a great deal more sunlight than the Earth's atmosphere, which is, of course, the example of Venus. So Venus is a very interesting planet in the solar system. Its atmosphere is 97 times as dense as Earth's atmosphere, and it receives more sunlight than Earth does. And it's thought to have a drastically greater greenhouse effect than Earth's, and this leads to its extreme surface temperatures of about 465 degrees Celsius. Sorry, I'm just going to relight my cigarette a sec. Oh, bloody hell. Always trying to find lighters or something like this. It's terrible. Yeah. So, Venus has a surface temperature of 465 degrees Celsius. So I was trying to reconstruct this from carbon dioxide levels in the atmosphere. So the first thing that I did is I just extrapolated from Earth using very basic calculations, really. So 420 parts per million is thought to, well, the extra amount of CO2 since pre-industrial times. Since in pre-industrial times it was about 220 parts per million. Now it's about 420 parts per million, so 200 parts per million of CO2 is thought to lead to 1.3 degrees of warming on Earth. So I was going to extrapolate that to Venus. Since Venus has 2,400 times as much CO2 in its atmosphere as Earth does, It has a parts per million concentration of 965,000 compared to Earth's 420. So it has an extreme amount of carbon dioxide in its atmosphere. And my initial thought was that this would lead to an extreme amount of warming, clearly. So I took the 1.3 degrees Celsius, multiplied it by 2,400, came out with 3,120. Then I thought, okay, it's receiving actually less radiation at the surface than what Earth does, because it has a greater albedo than Earth does, and its huge sulfur dioxide clouds in its atmosphere block up to 80% of the incoming solar radiation. So you can then, take 80% of 3,120 away from it, and then you arrive at something like 680, I think, Celsius at its surface, which is too hot, really. You can't really reconstruct the surface temperature of Venus quite that way. Um, and I put this onto a climate change open discussion group on Facebook, and they all came back saying, well, CO2 doesn't really work that way. It's a logarithmic scale instead of just, being able to use linear multiplication. And I was like, okay, fine. Well, we'll look into the equations then that use logarithms to try and predict how much radiative forcing there would be due to carbon dioxide in the atmosphere. And I did this. I took the equation of the form 5.35 times ln multiplied by ln being the natural log. Then that's multiplied by C over C naught, where C is the carbon dioxide concentration in the atmosphere that you're studying, and C naught is a reference point of carbon dioxide concentration. So for the reference point, I chose the 420 parts per million in Earth's atmosphere. From the C, I chose Venus's concentration of CO2, which is 965,000 parts per million. Did put those numbers into the equation, and it came out as 41 watts per meter squared. So that's not very much, is it now? For all the carbon dioxide in Venus's atmosphere, 41 watts per meter squared. Well, that's really not a very impressive greenhouse effect now, is it? I mean, if you think about that, if you try and put that number in context, Mars's atmosphere is thought to lead to only 18 watts per meter squared of warming. It's 70 times as much CO2 in its atmosphere as Earth's atmosphere. That's thought to lead to a greenhouse effect of only 18 watts per meter squared. So translating watts per meter squared into Celsius, which is what I was trying to do, and I was fumbling around with a couple of equations for a while trying to do this, but then I found online that you can just kind of multiply it by 0.31 degrees Celsius, and to get the amount of warming for an amount of watts per meter squared. And I found that the 41 watts per meter squared for Venus, that translates to an increase in temperature of 12.71 degrees Celsius. And I'm like, well, you can't really construct the surface temperature of Venus that way, can you? Or the greenhouse effect has an incredibly small effect when it comes to the extraordinary carbon dioxide concentrations on Venus. So 12.71 degrees Celsius warming on Venus due to the greenhouse effect on Venus, which, there isn't a stronger greenhouse effect anywhere else in the solar system. And the surface temperatures are extraordinarily hot. So what can I really glean from this? I don't know if that number makes sense or not, or really if that's a sensible thing to believe. I don't really know what to believe anymore. I don't know. I'm not closer to being able to reconstruct the surface temperature of Venus from its carbon dioxide content. I know that much. There could be an alternative explanation that the greenhouse effect actually has a very limited impact on Venus's climate, and that the overwhelming majority of the heat actually doesn't come from heat that's reflected by the atmosphere back down towards the surface. The vast majority of the heat is coming from its volcanoes. It has an extraordinary amount of volcanoes, and these are pumping out an enormous amount of heat, obviously. And if you look at the surface of Venus, it's pockmarked with these kind of volcanoes that sort of come out in kind of, well, like they just bleed onto the surface in kind of circular pads of magma, and yeah, that's kind of what Venus's surface looks like. Really, it's just potted with volcanoes all over the place, very short, squat volcanoes. So I was thinking about that, and I was trying to think that maybe it's not actually the atmosphere trapping all that much heat on Venus. Maybe it's actually Venus itself, the whole planet, which really is the source of the radiation, or the causing of the trapped radiation. If you see what I mean, the whole planet itself is trapping the radiation, then releasing it back by re-radiating heat from its surface via its volcanoes and so on, and it's incredibly hot surface anyway, and that it's really the internal dynamics of Venus which contribute to this temperature, and it has not all that much to do with the greenhouse effect. So, I mean, the next step obviously will be to apply these same equations to Earth's atmosphere and logarithmic scales and so on to try and come up with the amount of warming that could potentially be incurred from, sort of, say, if we burned all the coal that we have at the moment, and how much, like, parts per million is that going to increase Earth's atmosphere by? How much radiative forcing is that going to be? How many degrees Celsius increases in temperature is that going to lead to? And I'm tempted to say I don't think it's going to increase the surface temperature all that much. And I'm tempted to say that there's probably far greater benefits to burning CO2 in terms of its impact on vegetation and so on. And that, we know that Earth, 55% of Earth is accelerating in its greening. It's getting greener at an accelerating rate. 7% of the Earth is browning at an accelerating rate, which is largely down to changes in land use and not so much, I don't think, to do with global warming. And various other things. Yeah, I think the benefits of burning CO2 actually might outweigh the negatives of it, even from an ecological standpoint. And that sounds highly controversial. And I mean, I'm someone who has deep ecological sympathies. I'm not somebody who wants to see us destroying the planet via pollution and deforestation and all the terrible things that we definitely do that destroy the ecosystem. I'm just not sold on climate change and global warming. It's just an area of science that seems squiffy to me. It seems wrong. It seems like it's based on poor assumptions. And it seems to me as though it's based on an incomplete understanding of physical processes, such as like we don't know cloud climate feedback, for instance. We don't have good ways of modeling clouds. The mathematics apparently is just too hard for modeling clouds, and all these other problems exist with it. So I just can't believe in it, because I also care about truth. I care about truth and understanding and knowledge, and trying my best to understand nature and understand the universe, really. But it's just, and it doesn't lead me to greater understanding. I look at these numbers that come out of these equations, like 12.71 degrees C of warming, and I'm like, well, that's for 965,000 parts per million of CO2 in Venus's atmosphere. And if it's only leading to 12.71 degrees of warming, something is incredibly wrong somewhere. And there is no good mathematical formalism that allows us to predict surface temperatures from greenhouse gases. So I'm led to the only conclusion that I think I could be led to, that actually greenhouse gases don't have all that great an impact on surface temperature, and that really we're not going to die in these catastrophic heat waves and this hot house Earth idea. I think it's all a load of baloney, bullshit, nonsense. And I think the planet is probably going to cope with the increased levels of CO2 by becoming greener, which, let's face it, is only good for wildlife and is only good for the planet and life on Earth, and sponsors life rather than detracts from it. So I'm really unsure what to think about all of this. And yes, I disagree with pollution. Yes, I disagree with deforestation. I think we're absolutely murdering our soils and undermining our ability to feed ourselves. And I think the habitat loss and all this sort of thing, we're doing terrible things to wildlife on this planet. So yeah, yes, absolutely. I have a high degree of ecological concern, but I'm just not sold on this carbon dioxide business. And I don't think I'm likely to be. And I don't think the sophistication with the mathematical methods of climate change and the modeling, I don't see it being there. I think actually I came to a far closer estimate of Venus's surface temperature using the crude methods that I employed in the first place, just extrapolating from the 1.3 degrees C of warming on Earth, multiplying that by 2,400, then accounting for Venus's albedo and subtracting 80% of that number away, and coming to 685 degrees C of warming or so. That's closer to Venus's actual surface temperature than 12.71 degrees C is. Come on. Then I'm thinking, like, is carbon dioxide's radiative forcing really logarithmic? Does it really just like follow this curve that tapers off? Well, I assume that's been tested rigorously in laboratories. And I think because of the same reason, is global warming all that much of an issue if it's going to taper off at some point? I mean, we might be in the lower part of the logarithmic scale at the moment, where a doubling of CO2 roughly causes the same amount of radiative forcing, but as we increase more CO2, that'll level off, surely. I don't know what the fuck to think. So that's a roundup of where I am with it, all the climate science stuff. So if you like, leave a comment. If you liked this video, please leave a like. If you have anything to tell me, any kind of insights that might be useful to my investigations, yeah, please leave a comment suggesting what that might be. And as ever, I love you lots, and I hope for the best for this planet. I really do. But I'm not 100% convinced that CO2 isn't actually beneficial for the planet. So yeah, I'll sign off with that and wish you all the very best out there. Bye bye bye. I love you lots. See you soon.